Let the function f is defined like this. It's a function from integer to integer, from z to z. It's a function, okay? And f of x is defined. Just a second. F of x is defined as ax plus b. Okay. F is defined by f of x is equals to ax plus b for some integer a and b. We have to find the value of a and b. Find a and b. How to find it? Alina, Ali, Nofal is not there. Okay. How to find the value of a and b? Any idea? Ali, Alina? Do you want to try it? Otherwise, we can discuss it over here. Yes, Ali. Alina, what can be done to find the value of a and b? Any idea? Okay, let's discuss it over here. So what we can do here, we know that 1, 1 belongs to this function f, 2, 3 belongs to f, 0, minus 1 belongs to f, and minus 1, minus 3, these are the 4 elements which belongs to the function f, okay? So we know that 1, 1, it belongs to f. We can write it like this. In the set chapter, you have already learned. 2, 3, this ordered pair, this also belongs to f, okay? One more is there, 0, minus 1. This also belongs to f. And minus 1, minus 3. This also belongs to f. Minus 1, minus 3 belongs to f. Okay. Now, of a relation is given, f of x is equals to ax plus b. Okay. It is given that f of x is equals to ax plus b. Here, if this belongs to f, can we say when x is 1, then f of x is equals to 1 also. F of 1 is 1. Can we say from here? From here, can we say that f of 1 is 1? Can we? Ali and Alina? Yes or no? Can we say that when x is 1, then the function is 1, the output is 1? Yes or no? Are you there? Am I
Yes.
audible?
Yes, ma'am.
Are you
Yes, ma'am.
getting this step? Yes or no?
Yes, ma'am.
Ali, are you getting it? Can we say that f of 1 is 1? Because 1 is there in the function. 1 is there over there. Like in the function, the set which is defined already. In that set, 1, this ordered pair is there. So can we say when x is 1, then y is also 1, or f of x is 1, or f of 1 is 1? Can we say, Ali?
Yes, ma'am.
We can say that. And we are having this relation also. So here we will substitute x as a 1. X is a 1. That means here we'll be having a only plus b only, and here 1. Can you see one of the equation? Similarly, is it possible to make other equations also? Let's check it. Here, the second equation also we will be able to take like that only, that when x is 2, then the output is 3. And the relation is given, f of x is equals to ax plus b. So x is 2, that means 2a plus b, and the output is 3. If we will solve equation 1 and equation 2, we will be getting the value of a and b, and that's what we have to find over here. Or let's check for the next one also. It says that when x is 0, then the output is -1. Okay, that means here we can substitute it. F of x is equals to ax plus b. Here x is 0. X is 0. And the output is -1. So directly we got the value of b. No need to solve equation 2 and equation 1. The third element, the third ordered pair is already helping us to get the value of b directly. Now this b value we can substitute in equation number 1 and we can get the a value directly. Otherwise, we can also solve by the method of substitution or by the method of elimination. We can solve any two-way equation and we can find a and b. Whatever be the way, your a and b value will be same. Getting it? How to solve this type of question? What is a value? Tell me. What is a value? Ali and Alina, what is a value?
Two.
Is 2. Yeah. B is -1, A is 2, and we are done. Okay. This is the function is given over here. Basically, when we are talking about a function, there is an input, there is an output. There must be a relation. Like a we got here, ax plus b was there. A we got as a 2 and b we got as a 1, -1. Okay. Here, this is related to 2x minus 1. If you will give the input 1, you can check it. When you will substitute 1 over here, the output will come out as a 1. If you will give the input 2, you can check in the relation 2x minus 1. In this, if you will substitute x as a 2, you will be getting the output as a 3. If you will get input as a 0, you will get output as a -1. So this is how the function works. Whenever we draw the mapping diagram, that one is related to like 1 is related to 1, 2 is related to 3, 5 is related to 6. Whatever we draw the mapping diagram, that is related with the equation, with the expression, equation only we will be saying, because y is equals to something in terms of x. So we will, whatever input we will be giving for x, accordingly we will be getting the output. Getting it? Now there is a question. Suppose a function I am writing, a function f of x is equals to 1 by x. F of x is equals to 1 by x. randomly a function I have written, and I am asking you, please tell me what is the domain of this function and what is the range of this function. Alina and Ali, please check it. Yes, Alina and Ali, can you tell me what is the range and what is the domain? Think about it and let me know. Yes, what is the domain? Alina? Can you recall one day I was saying that everything is acceptable, but we will not be taking, we just try to avoid zero in the denominator. So if I will ask you what is the domain, what is the domain? Is it all real numbers?
R minus 0.
Exactly. Everything is acceptable, but the zero in the denominator, that is not acceptable. So what is the domain? Domain can be any real number, but the number which can make zero in the denominator, we are not allowed to take that number, and it is the number zero only, because x only we are having. In the denominator, zero is not allowed. Which value of x can create zero in the denominator? X value. When zero is there, that is not allowed. So domain will be all real number minus the number zero. Any confusion? Now tell me what is the range? We were discussing that always it will not be that simple to think about the y value. What exactly is the y value? Then what we can do, we can just change the equation. We can write x on one side separately, okay, and rest of the term on the other side. And then we can think about what can be the possible y value, just like the domain. Think about it and let me know what is the possible y value. Can you recall how we were discussing to find the range x? If we will shift it to other side, it will be 1 by y. Yes or no? Now, if I will ask you what is the possible y value, can you let me know? Just like the domain. Ali and Alina. Yes. What is the possible y value? Just like the domain. All real number minus. Wait. I think I have maximized it a lot. Infinity. Is it infinity? See, range will also be all real number. We will be getting any real number, but 0 we will not be getting. Range also we have to, you can take it like this. Let me show it to you. Just a second. Yeah, you can also see y is equals to 1 by x. How to think about the range? If you will keep on observing the equation, if you will keep on observing the given function, given relation, you will not be getting exactly what will be the range. This is short will guide you how to check what is the range. Okay, so whatever be the function, whatever be the equation, you can write it in terms of x. Whenever I am saying in terms of x, that means x separately on one side, independently, separately x on one side. You have to isolate x. Isolating x means keeping x on one side. X is equals to 1 by y. Now, what is the possible value of y? Just like domain, we can think that everything acceptable except 0. So, range will also be all real number minus 0. Now, let's get back to the actual function. Whatever you will be taking the value of x, will it come 0? Y value? Anytime the f of x, whatever you will be taking in the denominator, 1 by any number, will it come output as a 0? Is it possible? 0 is not allowed to take. What else? You can take any decimal number, any integers, like -2, -3, -4, -5, anything you will be taking. Is it possible to get the result as a 0? Is it possible? No. So output, the result will also be anything but not 0. Anything but not 0. Am I making sense?
Yes, ma'am.
Ali, are you getting it? Basically, we are thinking
Yes,
like
ma'am.
this, that what can be the possible value of x? Yes, Ali. First, let me know whether it is clear or not. Is it clear, Ali?
Yes, ma'am.
Okay, so this is how we will be thinking about it. Okay, let's move to the next question. Yes, Ali, you were saying that you are having exam, and there this concept will come, that is inequality. And I said to you that the like most important part of the inequality we have already discussed over here. Start solving the question. So just yes, Alina, you will also be able to relate it with. We are not starting inequality chapter. I am just giving you one question which you will be able to solve. If you have if you have understood everything, whatever we are discussing from day one. So I was saying that whenever we are having the inequality sign, greater than sign, lesser than sign, greater equals to, lesser equals to, everything is acceptable. But when we are doing the multiplication by a negative number or division by a negative number, that is not acceptable. That is, that time we have to just reverse the sign when we are doing the multiplication or division by a negative number. So let me take one question. Suppose we are having this 3x minus 2 over 5 lesser or equals to 5 2 minus x. This chapter is very important, and it is not just only in this chapter you are going to use this concept. These concepts you will be using while finding the domain, while finding the range. It is that important. Okay, so you need to know, before we will reach this chapter, we will do this chapter, you need to know the concept which is there. Okay, we have already discussed the concept. Let's do this question. So the concept says that, let's do it together. Okay, the concept says that the way you solve the equation, similarly you are supposed to solve the inequality. So how we solve the equation? Crisscross multiplication. Let's do it. This 3 will go to other side and this 5 will go to other side. Okay, so basically we will be having 3 into 3, that is 9, x minus 2, and here we'll be having lesser equals to 5 into 5, 25, 2 minus x. The way you solve the equation, similarly you have to solve it. Okay, only one place is there where we have to be careful. Now let's apply the distributive property. It will be 9x minus 9 2 times 18 less or equals to 25 2 times 50 minus 25x. So far, any confusion to anyone? No. Now this 25x we can shift to this side. It will be 9x plus 25x, and that side it will be 50 plus 18. Everything so far we have done just like a equation. Now we will solve it like a equation only. 25 plus 9. 33. X less or equals to 68. X less or equals to 68 by 33. This is how we solve the equation. Yeah, this is how we solve the equation, and this is how we are supposed to solve the inequality. Okay, it is 34. Wait. Oh yeah, thank you for telling me. Now we can do the cancellation also, and that will be the range. That will be the range of x. So x lesser equals to 68 by 34. That means, let's cancel it out. 2, 1 times 2, 7 times 14. 2, 3 times 6, 4 times 8. Yeah. 17, 2 times 34. Yeah. This is what we got, the solution. Previously, we used to get x equals to 2 when we were solving the equation. Here we are solving the inequality. We are getting x lesser equals to 2. We need to understand the meaning of that. X lesser or equals to 2 means the numbers which are smaller than or equals to 2. That is acceptable as a solution. So the solution can be 2. Solution can be 1. Okay, if we are supposed to write the integers only if we are supposed to write in the question only, the instruction will be there. Answer in integers. Okay, so we are supposed to take only integers from this solution. So 2 we can take, 1 we can take, 0 we can take, minus 1 we can take, minus 2, like this it will keep on going. These are all the solution of the given inequality. Okay, the way we solve the equation, similarly we need to solve the inequality. Now suppose there is a question like this. Yeah, this one. 5 minus 2x by 3 is lesser equals to x by 6 minus 5. Let's do it quickly. If you have understood the previous one, let's do it quickly. What we can do? We can keep 5 on that side only, or we can collect all the x terms on one side. Whatever you want, you can do at first. Okay. So basically we need to stick to BODMAS, and the simplification we must know. So 5 minus 2x by 3. There only we can do the simplification. X minus, like x by 6 minus 5, we can take the LCM and then we can do the simplification, or that x by 6 we can take to this side. Whatever you want, you can do it. Okay. Now what we will do, we will take the LCM. LCM is 3. LCM of 3 and 6 is Ali and Alila. LCM of 3 and 6 is LCM of 3 and 6 is yes.
3.
Is it 3? That is the HCF.
Ma'am, it
LCM,
is 6.
it is 6. LCM means we'll be taking the common part also and the remaining terms also. Okay. So 3 means 3 only. We are not able to do the factorization. 6 means 3 into 2. LCM means we will be taking the common number also and the remaining number also. So 3 is the common and 2 the remaining one. 3 into 2, LCM is 6. What will be there in the first terms numerators part? 3 2 times 6. So what will be there in the first term numerators part? Yes. Ali and Alina. See, in the numerators part, it's 3 2 times 6. So 2 will be there. Yes or no? Then 5 minus 2x minus x. Basically 3 changed to 6. That means 2 is multiplied over here. Similarly, 2, we need to do the multiplication in the numerators part also. Exactly 10 minus 5x. 10 minus 4x. 10 minus 4x. Okay, 4x and x, 5x. Yeah. So we will be having 10 minus 4x minus x over 6 minus 5. 10 minus 5x by 6 lesser or equals to minus 5. Till now we have done everything just like a equation. Now it's time to be careful. Okay, this 6 we will shift it to other side. We are going to do the multiplication with a number, but that number is 6, positive 6. So still we don't have to worry about the sign, inequality sign. It will be 10 minus 5x. Okay, less or equals to minus 30 will be there. Now here 10 minus 5x is this one. Now we have to keep x on one side and remaining terms on the other side, the constants. So 10, if you will shift to other side, we are allowed to do addition and subtraction. We are allowed to do addition and subtraction with a negative number, positive number, doesn't matter. If you are adding it or subtracting it, doesn't matter at all. Okay, so minus 30. And then this 10 will go to other side, minus 10. Minus 5x is smaller than equals to minus 40. Now x smaller than or equals to, we will be thinking about the sign afterwards. But at first, let's shift this minus 5 to other side. It will go in the denominator of minus 40. And recall, again and again, I am telling you, whenever we are doing the multiplication or division by a negative number, we have to reverse the sign. So this sign will get reversed. Getting it? X greater or equals to 5, 8 times 40. This is the answer. If we have to represent this answer on the number line, we will be drawing a number line, a real number line. 0, like 1, 2, somewhere 8 will be there. X is bigger than 8. So we can represent like this. An equal sign is also there. Whenever equal sign will be there, we will be drawing a solid circle. A solid circle we have to draw. That means our solution is touching 8. Okay, this is the solution for x greater than 8. That means on the right of 8. And solid circle is representing that it is touching 8. Okay, when your solution will be just x greater than 8, then you will locate the solution like this. A hollow circle and then like this. That means we are not touching 8. We are not able to touch 8. Like after 8, we can take all the number, but not 8. That's why hollow circle. And when we are touching 8, that means solid circle. This is basic concept of inequality, which is not limited to inequality, which is limited, like we'll be using these concept in all the chapter. We'll be starting in the next class, we'll be starting the trigonometric functions. Yeah, there also we will be talking about this solid circle, hollow circle. So this is the basic you should understand. Okay, this is the basic. When x is bigger than 8, hollow circle, and bigger than. Okay, when x is bigger than and equals to 8, that means solid circle and line like this. Or directly on the line also, you can just make the line bold. From 8, a solid circle, and then you can make like this, a bold line you can, and an arrow you can make. So like this you can represent, or like the first one. Are you getting it, Ali and Alina?
Yes, ma'am.
Yes, Ali, are you getting it? If these concepts are clear to you, then you will be able to solve the first, like most of the question from the first exercise of linear inequality early. Do try and let me know in the next class whether you were able to do it or not. Okay.
Okay, ma'am.
Now the question which I want to discuss over here is this one. See, domain and range must be crystal clear to you. I'll write a function and you will start finding the domain and range. What is the meaning of domain? What is the meaning of range? You should understand it very well. Okay. Now one question is there. Let R be a relation from natural number to natural number defined by R is equals to set of all ordered pair AB such that A and B both belongs to natural number and A is equals to B square. Are the following true? Number one is AA belongs to R for all A belongs to 1. Okay. Number two, true and false. This is the question where we just have to say whether it is true, whether it is false. Okay. AB belongs to R implies BA belongs to R. And number three, AB belongs to R, BC belongs to R, implies AC belongs to R. You have learned very well the concept of relations. Okay, relation we have covered in the first class only. Let me know whether the given statements are true or false. R be a relation from natural number to natural number. Previously, it was very like the set was small and it was easier to check. Now the set is infinite set. That's why it is getting a little bit tricky. Okay, so natural number to natural number, R is a relation is there. Relation is defined like this. We already understand relation means what? A condition will be given in the question. Accordingly, input output will be there, right? Now it says that is it true? A belongs to our A type of element. Does it belongs to our relation? If we will list down few ordered pair, natural number to natural number, let me write the relation. The relation is defined as set of all ordered pair AB such that A and B both are natural number and A is equals to B square. This type of relation we have seen a lot of time. Here only the difference is natural number. So what? We will try writing few ordered pair. Let's write few ordered pair. Let's take the first natural number 1. Okay, 1. So according to this condition, ordered pair we have to create. So if we will take A as a 1, B will be A is equals to B square. Can you tell me what will be the first ordered pair? Can you tell me? Ali and Alina, if suppose we are taking A is B square. Suppose we are taking B as a 1, then A will be if you took B as a 1, then A will be, yes, Ali and Alina. Third one. Alina, you said. Okay, I will show the third one. Let's start from the first one. Okay. Yes, I'll come to the third one. Okay, you are noting it down. Yeah, see, this is the question. I thought you are talking about the solution of the third. Okay, no worries. Noted? Yes, Alina, noted. Okay, let's move. So let's write few ordered pair. A is B square. A and B both are natural number. A and B both are natural number and A is what? B square. So if B we have taken the first natural number, A will be square of that. Got it? If B we will be taking the second natural number, A will be square of that. If B we will be taking the third natural number, A will be square of that. If B we will be taking the next natural number, A will be square of that. Getting it? Like this, we will be getting the ordered pairs. Getting it? Let's check. A belongs to R. That means both the element ordered in our ordered pair, both the element will be same. That belongs to R. For all A belongs to. For all natural number, is it possible? For all natural number, is it possible? All natural number, that means for 1 also is there. 2 is also there. 3 is also there. 4 is also there. Is it there in our relation? Is it there? Check it. 1 2 3 4. Is it there? No. It is not there. So the first statement, is it true or false? If all word is there, all is signifying that every time, whatever a, so whatever like natural number you will be taking as a the ordered pair is doublet, like 1 1 2 2 3 3 4 4 5 5. It's there in our relation, which is not true. So this is false. Yes or no? Always it is not true. Is it clear so far to both of you? It's from relations. Relations we have already discussed. Is it clear? Let's do the next one. AB belongs to R implies that BA also belongs to R. That means if we are having 4, 2, then 2, 4 will also be there. 2, 4 will be there. 2, 4 will it be there? Will it be there in our relation? Will it be there? Yes or no? Yes or no? Will it be there if 2, like 4, 2 is there, this ordered pair is there, then the reverse is also there, yes or no? Is it there? We have to follow the condition given, A is equals to B square. Is it for fulfilling the condition given? Is it possible to get this ordered pair? Yes or no? This is fulfilling the criteria that A is, wait, that A is B square. B we have taken as a 2, A came out as a 4. But is it possible to get 2, 4 also? Yes or no? Ali and Alina, क्या ये पॉसिबल है? 4, 2 तो है, वो रिलेशन का जो कंडीशन है A इज इक्वल टू बी स्क्वायर, उसको फुलफिल कर रहा है. लेकिन 2, 4 हमारे रिलेशन में होगा या नहीं होगा ये ऑर्डर्ड पेयर? यस, चलो ध्यान से समझते हैं. यस अलीना, यू वर सेइंग समथिंग.
No, ma'am, it's not possible.
It's not possible. The second relation says that if AB is there, then BA will also be there in the relation. If AB is there, then BA will also be there. So we have listed down few ordered pairs for our clarity, and we are trying to understand from here. So we are taking one of the ordered pair, that is, let's say the second one we are taking. Let's say the second one. And we are checking if 4, 2 is there. It is there in our relation. We have listed it down by using the given condition. A is equals to B square and A and B both are natural number. Okay. 2, 4, 2 is there in our relation. But we are checking whether 2, 4 is also there or not. It is not there because 2, 4 will not fulfill this criteria. It says that A has to be the square of B. A is not a square of B over here. 2, 4 is not there. So we can see one of the element 4, 2 is there. 2, 4 is not there. So this is not true. AB is there implies that BA has to be there. No, it is not true. It is not always true. Getting it, Ali? Yes, Ali, getting it?
Yes, ma'am.
Let's do the next one. Now it says that if AB is there, BC is there, then AC will also be there. AB is there, BC is there, then AC will also be there. Let's check it. Let's check whether it is possible or not. Let me wipe the previous scenario. Let's make few more ordered pair just for understanding. Otherwise, you without even writing the ordered pair, you have to think But how? We are coming to that. Let's take the help of ordered pair first. So if we are taking A, not A, B. Just a moment. If we are taking B as a 5, B as a 5, then A will come as a 25. If we are taking B as a 6, then A will come as a square of that. If we are taking B as a 7, then A will come square of that. If we are taking B as a 8, then A will come square of that. If we are taking B as a 9, then A will come out square of that. If we are taking B as a 10, then A will come square of that. If we are taking B as a any number, any natural number, the A will be square of that. We have understood the given condition, the given relation. This is how it will keep on going and keep on going and keep on going, because natural numbers are infinite natural numbers we are having. Now it says that if AB is there and BC is also there, then AC will be there. Okay. So for example, here you will not be able to understand. If AB is there, that means A is equals to B square. It must fulfill this criteria. And BC is also there. That means the first element is equals to the square of the second. That's what the relation says. The relation says that whatever ordered pair is there, whatever A, B, B, C, X, Y, Y, Z, the first element is equals to the square of the second one. That's what the relation says, right? So AB we can write as A is equals to B square. BC we can write as a B is equals to C square. Now we have to check. We have to check by using this equation number 1 and equation number 2 whether it is possible to get AC. Whether AC, that means the first element is equals to the square of the second. Whether it is possible to get A is equals to C square by using equation 1 and 2. Whether it is possible. If it is possible, then yeah, AC also belongs to the given relation. If it is not possible, then no. AC will not be there. Okay. Tell me, Ali and Alina, whether it is possible to get A is equals to C square over here. If you will use equation 1 and equation 2, and if you will apply the method of substitution, so at the place of B square in equation 1, B is equals to C square, substituting in equation 1. This B value, whatever is there, we are going to substitute at the place of B in equation number 1. That is A is equals to B square. B we are going to substitute. C squares whole square. Okay. Are we getting? What are we getting? Tell me. A is equals to what will be there? Ali and Alina. Yes. A is equals to C to the power 4 we are going to get. Yes or no? Yeah, exactly. We are going to get A is equals to C to the power 4. But we are expecting for AC belongs to R means A has to be equals to C square. We are not getting this. We are getting something else. So we can say the last statement is also not true. Okay. Just a second. Let me check whether it says, or like if always it doesn't say, then it can be right also. Just a moment. Let me check in the book. Yeah. Always it says, that means implies is there. That means we need to take always. Always it is true. No. This is also false. So let's summarize everything what we discussed. The relation is given over here as A is equals to B square. Okay, relations and functions almost we have covered. 2 3 functions are there which we will be doing, but these questions are very important. If you will get such question in exam, you will think that relation you have understood the concept, but you are not able to do questions like this. So you should practice as much as possible. A is equals to B square, this is given in the relation. Okay, we have to check whether the first, the second and the third statement is true or false. Okay, so we are checking it. The first one is saying that A belongs to R. For all A belongs to natural number, which is not true. We have listed down the few ordered pair and we checked it. It is not true. The second one also we realized from the ordered pair which we have listed down in our relation. The second one is also false. The third one exactly we were not able to, like we were not getting in our relation. Okay. But if we checked it by ourselves that AB belongs to R means A is equals to B square. BC belongs to R means the first element is equals to C square.